Same kind of analysis will be valid for that also, only circuit is like this. Two diodes are used instead of a single diode, and at any instant of time this is plus EM, peak is plus EM, this will be minus EM, this one, with respect to ground. So, when this is positive, this will be negative and vice versa. So, for positive half cycle, this probe will conduct and then it will go through this diode, conducting diode, and comes here and gives you a half cycle corresponding to positive part. And for negative side, this diode will conduct. In this sense, when this is negative, this becomes positive. So, this will conduct and give you a current again in the same direction. Okay. This is not a push-pull, but a push-push. Both sides is in the same direction. Average value of this VDC is obviously twice of that, because that is only for half and this is for full. So, 2 EM by pi. And ripple, we can quickly see the basic formula for ripple is equal to this minus this, and now here it is going up to 0 to t because both sides are there, and whether it's square, when you square a sine wave, it will come to the same thing, 2 halves, right. So, the first term will be equal to EM square by 2 in this, because that is the full wave. So, because of that the RMS value will be same as the sine wave. So, RMS square will be equal to EM square by 2, and VDC we have already seen is equal to 4 EM square by pi square. So, the VRMS square of the ripple will be given by this. Without much of calculation, you can quickly see, and you can now do the same thing, the ripple factor which is equal to E VRMS of ripple divided by VDC, right. We know VDC, we know RMS value ripple square root of this, and then EM cancels. So, if we calculate it comes out to be 4.48. So, the full wave rectifier is a much better performer as a AC to DC converter compared to a single phase, a single wave half wave rectifier, single diode rectifier, but the problem still is 0.48. I still have to bring it down to a much lower value. What is the what is the first term in this waveform? Here it is 50 hertz, and how much will this be? How much? How many will say 50? How many say 100? 50. Nobody is saying 50? How many will say 100? Nobody is saying anything. It is an even function, right? Since in even function, the even function will only have even harmonics, right. So, because only has even harmonics, the first one will be equal to twice the frequency of 50. So, the problematic case here will be 100 hertz. The next one will be 200 hertz, 400 hertz, and so on and so on, because the evenness of this waveform, and it is comparatively easier to filter out 100 hertz compared to 50 hertz, but we don't put a filter in the conventional sense, but we will put some kind of a filter after this to reduce this components corresponding to the ripple components, to reduce this factor. Unfortunately, for analysis purposes, if you put a filter here and put a resistance, load resistance here, a low pass filter, cut off after below 100 hertz. Unfortunately, filter affects the performance of the diodes. So, it is not independent. So, the presence of the filter will change the performance of the full wave rectifier. So, we can't in a simple minded think about filtering by putting a filter after this, because the filter itself affects the performance of the rectifier itself, as we will see just now. But in some simple mindedness, it is some kind of filtering takes place here, so that we improve this value to a much lesser value compared to 0.48. One technique, simple technique of improving this is the following. Now, let me, before I go to that, let me say a few more words about this. This requires two diodes, and then this requires a center tapped output winding of a transformer, because normally transformer does not have a center tap. So, you require a transformer with a center tap. That is one disadvantage. The next one is, if this is EM, we are asking for 2 EM here, so this is right. So, the transformer winding must have something like 1:2 ratio, which obviously requires more number of turns here, and more number of turns with the diameter of the wire being equal to current flowing in this. So, you have more copper here, because more number of turns, more amount of current, but it has to be a center tap transformer. But the blessing in disguise is that one current is going like this, and other current is going like this, right. One half it goes like this, other half it goes like this. The average value in this is same as the average value in this. So, there is no DC current flowing on this winding, which amounts to that your core does not carry a stationary flux. So, the core dimension can be much less as against a single, half wave rectifier, where the DC flows to the winding. As a result of that, the core size has to be larger compared to a full wave rectifier. So, that is a blessing in disguise, that the DC does not flow through the coil here. But still require, with all this good things said about it, normally they sell this transformer at a much higher price compared to a thing without without the center tap.